Okay, so we have information about a couple of events here, and based on the chances of these events happening, their probabilities, it's possible to tell whether they're related in certain ways, like whether they're mutually exclusive or whether they're independent. There's mathematical tests for each of those things, so let's see if we can get those working. If two events are mutually exclusive, I'll just use ME for that, it means the events cannot both happen at once. So they're things like the fish is alive, the fish is dead. You can't have those both happening simultaneously. It's one or the other. These two events, just looking at these numbers, it's not obvious that they're mutually exclusive, but there's a test that goes like this. Two events are mutually exclusive if and only if the chance of either one of them happening is equal to the chance of the first one happening plus the chance of the second one happening. This won't always work. It only works for mutually exclusive events. So in this case, if we have the chance that either one of these events happens, A or B, is 3/5. I'm going to plug these numbers in and we'll see if this equation holds. The chance of the first event is 1/3. And the chance of the second event is 2/5. Okay, if I want to add these, I need a common denominator, so I'm going to turn everything into 15ths. Multiply this first fraction by 3/3. And multiply this by 5, top and bottom. And multiply this by 3, top and bottom. And we get 9/15 equals 5 plus 6 is 11/15. No. This equation is not holding, which is the math telling you, no, these are not mutually exclusive events. So the fact that they're not mutually exclusive means they could happen at the same time. They're not things like alive and dead. They're things like it's raining outside and I'm going to have waffles. Those things can happen separately, but it's also no problem at all if they both happen at once. There's nothing about one of those events that makes the other one impossible. So these two are not mutually exclusive events. That means there is some overlap. Second part, independent events. Events are independent if they have nothing to do with each other. You can have events like it's Wednesday and it's raining out. And those two events have nothing to do with each other. The chance of one happening has nothing to do with the chance of the other one happening, because the weather has nothing to do with how our calendar works, and what day of the week it is has no effect on what the weather does outside. So things like Wednesday and raining are independent events. Events can be dependent if you have something like it's raining out and I'm going to have waffles because rain is depressing, but waffles make me feel better. I might be more likely to go make waffles when it's raining out. Those two things could be connected. I might even have a ritual where I always make waffles on rainy days, and then those events are strongly dependent. The chance of, if rain happens, then definitely it's waffle day. So, the mathematical test for this one kind of looks a lot like the mutually exclusive test. It goes like this. It says the probability of A and this time B equals, and this time we're not going to add the probabilities, we're multiplying them. Events are independent if the probability of A and B is the probability of A times the probability of B. Now we have PA and we have PB. The trouble is we don't have A and B, and there isn't any simple way to find it. They gave us A or B, which is not at all the same thing. So we're in a bit of a bind here. But there is a way out of it, and the way out involves this. If these two events combined happen 3/5 of the time, the negation of this would be that neither A nor B, I'm putting a prime symbol on that, will happen 2/5 of the time. Right? 3 times out of 5, one of these things happen. the other 2/5 of the time, neither of these things happen. And so this, A or B, neither of them happened, is equivalent to not A and not B equals 2/5. Okay, I'll go through that one more time. This is saying either A or B, or maybe even both, will happen 3 times out of 5. That means neither of them happens. We strike out on both events 2 times out of 5. Fair enough? That's the hardest part of this whole section. So if you're good with that, then you're going to be fine. So neither of these things happens 2/5 of the time. We could set this up to use the probability of not A and not B would have to be the probability of A not happening times the probability of B not happening. So they didn't give me what I needed to work with A and B, so I'm going to work with not A and not B. They can be independent as well, and if not A and not B are independent, that means A and B are independent as well. So let's see if we can get this working. The probability of not A and not B is 2/5 equals the probability of not A. What's the chance of A not happening? A does happen 1 time out of 3, so A doesn't happen 2 times out of 3. And now for event B. B happens 2 times out of 5, which means it doesn't happen the other 3 times out of 5. If we clean that up, 2 times 3 is 6, 3 times 5 is 15. Reduce the right-hand side by dividing top and bottom by 3, and lo and behold, we get those two sides are equal. So we set this up saying these events are independent if this equation works. That equation did work, which means A and B are independent. Usually the test isn't that much work, but in this case they didn't give us the information we needed. They didn't give us A and B, so we had to get a little sneaky.